Hello, dear colleagues. I'm very glad to be here today and to talk about the factors of the development of math skills in preschool age. It is one of the idea of this conference, and I want to talk about the results of a longitudinal study which was conducted in cooperation of Maриной Васильевой, the professor of Boston College. You can hear her presentation on Monday, and Alexandraм Вераксой, who is the head of the Department of Educational Psychology in Lomonosov Moscow State University. So in this, in my today presentation, I will talk about two groups of the factors which affects the development of early math skills and knowledge in preschool, school age children. And the first group of these factors is the executive functions. And we try to analyze the relations between all three main components of executive functions and different math knowledge, because many investigations shows that executive functions play a meaningful role in the development of preschool year, affects the development of their future math results at school too. And first I want to say a few words about the executive functions. It is a group of the cognitive skills that help us to control our cognitive thinking and behavior. And they provide control and monitoring of thinking processes, help us to adapt to a new situation, to new tasks. And according to Miyake model, there is three main components of executive functions. The first is a working memory, the visual and verbal working memory, and especially not only the store of information, but the updating of information in memory. The second component is cognitive flexibility and or shifting, and the third component is inhibition, the ability to suppress some distracting information and to focus on the most important parts of the task. So we use 4 different methods to measure all these 3 components to assess the development of visual and verbal working memory, the memory for designs and sensitive sentence repetition tasks. We use dimensional change card sort task to measure cognitive flexibility, and inhibition tasks as a subtest of NEPSI-2 diagnostic complex to measure inhibition. And then we tried to assess number skills in preschool year children. And we use writing, reading tasks, the tasks of number identification, when children shows 2 numbers, and for example, when on the page is number 87 and 87, yeah, children need to show us 87, for example, one of them. And the counting tasks, number comparison tasks, okay, and number representation tasks, when children need to combine number using these kinds of blocks. And more than 300 children take part in our investigation, and they're almost divided in girls and boys. When we analyzed our results, we divided all the sample into 2 groups with a low and high level of executive functions. And children with low level of executive functions have a lower level of visual working memory and inhibition. they make more mistakes, and these tasks took more time for them to analyze information. And we can see that children with low and high level of executive functions have significant differences in all the math tasks. For example, here you can see the differences in task implementation of writing, reading, and identification tasks. Here, differences in counting tasks. And here, the differences in number magnitude comparison tasks. So these results show us that we need to take into account the level of executive functions when we try to develop math skills in pre-kindergarten children, not pre-kindergarten, preschool children. Sorry, it was a slip of my tongue. And then we try to analyze which component of executive functions play more meaningful role in the development of math skills. And in this table, we can see that all three factors, we divided all executive functions in three factors, and all components took place in the development of math skills. But here we can see that inhibition usually play more meaningful role. And here we can see inhibition play more meaningful role, and here we can see that, for example, number reading is don't relate it with the verbal working memory and cognitive flexibility, and counting don't relate it with this factor too. So, and then we analyzed how children in a year, and the end of the kindergarten solve with math tasks, and we analyze that executive function is a predictor of their results in year 2. But when we talk about the development of preschool children, we need to take into account not only their individual differences. Of course, we need to analyze the social situation of their development. That's why we try to analyze the beliefs of their parents and what home math practices they use while they try to teach their children some math knowledge and math skills. And we compare the results of the test at the end of last kindergarten group of the children and the beliefs of their parents, and we collect the data of about 100 of children and their parents. We use some special parental questionnaire where we see the frequency of parent-child activities, different activities, and parental beliefs about the importance of math development, how it's development in childhood, and how they feel that they know math. And the math activities was divided into 2 big groups. One of them was the direct activities, when parents use some formal tasks and try to teach their children how to write numbers, how to read them, how to do some elementary arithmetical tasks. And the second group of activities was about indirect effect. It was some daily activities which related to math learning. For example, when a child needs to measure number of ingredients to prepare some dish, or for example, when he discuss time with children or some prices, and we found very interesting result of connection between parents' beliefs, the activities that they prefer to do with the child, and the results of a child assessment. And here you can see that if parents think that it is important to prepare child to school, and that math play a meaningful role in its education, they prefer to use direct math activities, and its affect number identificational skills of children. Instead of that, math self-understanding of math value, and when parents feel that he have a good level of math development and feel self-efficacy in math, his own self-efficacy, he preferred to use some indirect math activities and its effect on numerical magnitude understanding in children. It's better develop their understanding of how the symbol of number related with the results. And the last result, I will take not more than a minute, okay? That both direct and indirect math activities are related with the arithmetic skills of children, and they took place between the beliefs and the results of the children. So, our future plan to analyze how the teachers' kindergarten beliefs related with the success of their children too, and to analyze how executive function predicts the development of our longitudinal sample in the first grade too. Thank you for the attention.
Dear colleagues, let me introduce myself. My name is Elena Lazareva, and I work at the Tom State University. My colleague Irina Ustinova worked at the Tomsk Polytechnic University. Our communication is called the influence of motivation of students' achievements when studying MatCat. For every teacher, the interest of his student in the subject of study is important. When the students themselves seek to obtain high quality knowledge, they do not need additional external motivation. But it has been shown that the growth of academic achievements at the beginning of training strongly correlates with the level of students' intelligence, while further growth of academic achievements is more associated with the trainees. There are here same definitions of motivations. I could see that me and my colleague is not a psychologist. We are mathematicians, but this theme is very interesting for us, and the purpose of our work is to study whether it's possible to influence the achievements of students with the help of learning motivations. This is the design of our research. The first year students study MatCat for 8 weeks in the separate subject. The second year students study MatCat of applied it to problems of probability theory and mathematical statistics. For the first 8 weeks, all of them have the same MatCat study program. And then the first year students stop studying MatCat, and the second year students begin to use MatCat to solve problems in the probability theory and mathematical statistics. Students of both groups passed the same control test after 8 weeks of studying, and then after 16 weeks of studying. Excuse me. The teacher is Irina. She informs second-year students that they will need to use MatCat in another course. And the task of our research is to find out whether such motivation influences students' achievements. We have compared the results of the control tests after 8 weeks of the same studying, and we also compared the results of the first-year students and the second-year students after 16 weeks of study at the end of the term. No, we use some statistical tests. And the question one is, does the fact the students will need to apply the knowledge about MatCat in another course influence their test results? And question two is, does the real use of MatCat in the course of probability theory and mathematical statistics influence on the student test results? In this slide, we presented one of the variants of the control test, but only 2 tasks of 9. And also, you see the student solution of these 2 tasks here. The first result we received after 8 weeks of teaching were unexpected. Only 79% of the first-year students participated in the testing, and the average score they got was about 5.8. And only 39 second-year students participated in testing with the average score of 4.3. And these the results of the Mann-Whitney U-test. They say that we compared the results of each group of the first course. Each group of the first course consists of 18 students. The test shows the student of the first group passed the control test somewhat better than the students of the second course, since 84 is larger than 81. This is the U-test. And the students of second group passed the test significantly better than the second-year students. But the students of the third group passed the test in about the same way as the students of the second year. And our first conclusion is the motivation for the further use of knowledge did not give a positive results. The first year students were generally better prepared for the test and are more interested in taking it. Here are the final results of the for the all students of second year and first year after 16 weeks of training. And conclusion is the results of the second year students are not statistically different from the result of the first year students at the end of course. The result of the second year students improved after applying MatCat to solve problems in probability theory and statistics. Here are the final test results, only for students who have passed the test. 75% of the first year students passed the test with an average score of 6.1, and the second year students 78% passed the test with an average score of 7.1. But it is a student t-test, and they show that the second year students turned out to be slightly better. The result of the second year students, yes, turned out to be slightly better than the result of the first year students and the end of course. And so our conclusion, we believe that the learning outcome was influenced more by the experience gained in applying knowledge than the proposed motivation. The internal motivation of first-year students may have been stronger, but they did not have sufficient opportunities for its implementation. Therefore, after the end of training, the results of first and second year students become some equal. Increasing motivation does not directly lead to better learning outcomes. In the educational process, it's necessary to offer students the opportunity to turn their motives into the reality. Thank you for your attention.
Colleagues, I highly appreciate you choose this session today, and I'm glad to continue our colleagues' topic about motivation from Tomsk. And today I would like to share our actually practical experience on the formation of socio-psychological adaptation at the Mechanics and Mathematics faculty at Perm State National Research University. And I would like to emphasize that I'm a representative actually from psychological practice approach. And this topic is a case study, so we have a part that is connected with scientific research, but this is mostly a case study. So a little bit about our university. We have a strong traditions of math education at Perm State University, as this is the oldest university in Urals, and this is the first educational institution that began to carry out higher professional education. And that was opened as a branch of Petrograd University in 1916, and from the very beginning, having a solid support in the face of professors of St. Petersburg University, our scientists immediately took leading positions in mathematics. So, and we continue our strong tradition, and nowadays our university is about 13,000 students, and actually mechanics and math faculty is one of the biggest, and also this is the first faculty in our university. And we have two branches nowadays. One is connected with mathematics, and in our one is connected with computer sciences. And you also can see that our students are successful in computer sciences, so they participated in international contests during last 7 years, and they even took some good prizes at these competitions. I think that Yandex could be interested in our graduates too, because they are successful students. And the overwhelming number of our students, they study at the budgetary basis. So they don't need, for our international colleagues, they don't need to pay for their education because of the government. And the problem that we have at these faculties, you can see some of the graduate programs, the problem is that most students who study on a contractual basis, they as a rule don't complete their education before graduation. We know this is rather difficult to study mathematics, to study computer sciences disciplines at the university, and probably the reason is in the difficulty of the content of the disciplines. But the problem that we faced and that we got actually from the administration of the faculty was the dynamics of the number of full-time students at the university. So from the table we can see that despite all the tricks of accounting, the number of graduates who successfully completed their studies doesn't exceed 50% or 45% of those who enroll in the first course. And this is the problem because we need to provide the better level of our educational system in terms of education at the university, but we also need to maintain the quality of education. And this is some controversial task for university education. And Andrey Gennadievich Kuznetsov, he is the Dean of Mechanics and Mathematics faculty. He asked us, a psychologist, the following questions. Why students who pass the Unified State Exam, in Russia this is EGE, for maximum points cannot successfully study at university? So we also discussed these problems with our colleagues from Moscow State University of Physics and Informatics and from ITMO University in St. Petersburg. And this is an up-to-date problem because about sometimes 40-45% of students, they cannot continue their education, especially on the first course. And there are some typical difficulties faced by students like high study load, unusual work schedule, high knowledge requirements and new requirements from university teachers, a new academic group. But of course there are some other factors that we can see right now. And from a psychological point of view, the thing is that we focus our attention on cognitive development in school, in child school, and this conference, I think that also a significant issue because we are thinking about how to develop the way students, school students and pupils resolve some mathematical tasks, but what is about their personality development and their ability to study and to learn. And so firstly we were trying to find some methodological basis in Russian literature, and we found interesting researches by Ovcharova, Trofimova and Berezhkovskaya. And in the results of the author's research, it was shown that first year students, so they are about 18 years old, they have high rates of socio-psychological maladjustment. They are characterized by underdeveloped properties of self-awareness. They have low level of communication skills, activity, and low social status. So the lack of these properties formation makes it difficult to adapt in new students group, causes serious problems in mastering the program during training activities, and as a result leads to low academic performance. And on the other hand, there are some characteristics that help students to successfully adapt to new educational environment. Among them there is personal maturity, high level of self-awareness, and involvement in communication and activities. And we also organize a kind of empirical study. We actually provide some diagnostic for students following this methodology to understand what are the specific features, psychological features for students of mathematics and mechanics faculties. So you see we use individual typological questionnaire about introversion, extroversion, then anxiety and so on. The method to diagnose socio-psychological adaptation, and also the method of diagnostic students' educational motivation. And the most significant that we identify the risk zone students. About 40% of first-year students fall into risk zone due to their low level of adaptability. I think this is a widespread idea. And also students were characterized by external motivation. They are focused on the opinions of others. They were driven by others' ideas and not always independent in making decisions. So they usually choose the university in their 18s by their parents' and teachers' advice. And of course, another one point is that when performing training tasks, first-year students are guided not by their own interests, but like in school, they prefer to be oriented on the rules, norms, at position not to get a bad grade. So also we provide some analysis of correlational analysis between scores in unified state exam and the success in academic performance in algorithmization and programming course that is the leading for IT students at our university. And this is significant to put our attention at the standard deviation is the score that shows us there are significant differences in the first course after they have rather similar results in United States exam. And actually I would like to point your attention and the thing that we provide some program for socio-psychological adaptation. I will skip 2 slides. So this program was a joint program, and in this program participated our vice rector, administration of our university, the dean of mechanics and mathematics faculty, psychologists, and also teachers of mathematics and computer sciences discipline. So firstly, we organize the problem areas in first year students. This is low level of school preparation when we coaching our students for unified state exam, but there is a big gap sometimes in their knowledge of fundamental issues. Insufficient internal motivation of students because they are focusing on achievements but not on the inner aspects of knowledge. Low level of socialization and lack of understood some value orientations, and of course such factors are family relations and low family culture. And in order to increase this situation and to develop this level of socio-psychological adaptation, we provide some advices for our administration. So first of all, this was educational methodical support. You can see this is connected with increasing the volume of classroom hours. It is also important to increase in the time of direct contact of students with teachers, because as we know in Russian tradition, this is a long distance between university teacher and students. That's why sometimes they lost the interest. Providing leveling courses for those students. Of course, we have talented students, but some of them have a gap in their knowledge. That's why it's necessary to provide this help for them. Psychological pedagogical facilitation, it includes some training programs and personal counseling. Even work with students' parents, that is, as it was shown in Berezhkovskaya approach. So now the teenagers is age until 20. That's why we organize psychological counseling and meetings with students. And of course, career guidance with school children from the very beginning, because we should be oriented not only on those students who are successful in math in their school programs, but also maybe on those who are at the time oriented in the humanities. And I would like to conclude by the fact that the result of this realization of the program is that at our university we opened a center for psychological and pedagogical assistance. So now we transfer the experience of socio-psychological facilitation for other faculties, and now our students, tutors and teachers have an opportunity to ask for psychological and pedagogical help from the practical point of view, not only from science. So thank you.
So hello everybody, I know I'm the last presenter and it's lunchtime, so you might be tired. I do my best to finish in 10 minutes. I'm Morteza from National Research University. I'm a postdoc fellow there. And today I'm going to talk about the school engagement and math performance rating from students and teachers in Russia. Here with my colleague Alexey, Anastasia and Mari from our university. Yes, in the beginning I should mention that this is a small part of a bigger running project in Russia funded by Russian government, and also I'm going to present a small part of our finding here. So first I should, I think, give you a quick definition of what is school engagement. A school engagement is a degree to which students are cognitively, emotionally and behaviorally committed and invested in the learning process in a school. And you may ask me why school engagement is a timely and important topics. Yes, there are a lot of studies showing that school engagement is linked to important outcomes, like as you can see here, is connected to educational dropout, successful completion of the school. And also we conducted a study in Italy in 2015, and our study showed that students that are high on a school engagement are less likely to get involved in health risk behavior. Health risk behaviors like consumption of alcohol and stuff, smoking and things like that. So as you know, mathematics is also an important subject in school, and why mathematics is important because it has a central role in the future of each student. If you want to get involved, if you want to get in a good university, for instance, or if you want to get a good job in the future, so you should have a good mathematical skill. So that's why here we are trying to understand how school engagement can predict the math performance in school-age children. So here we have actually one simple goal is to understand how teachers and student ratings of a school engagement can predict the math performance in a school. So we actually collected data from a student, self-report using self-report scale, and also we collected data from their teachers, and we wanted to know which one can better predict the math performance of a student in the school. So let's a bit talk about demographic information of the sample. So we collected data from 100 Russian school-age children, plus their teachers also were recruited. Age range was 6 to 12 years old, and we used simple random sampling test. So the data was collected from public schools in Russian schools. So we actually used just 3 surveys. First, we used a school engagement scale developed by Frederick 2005, and it has 3 dimensions, behavioral one, cognitive, and also emotional one. I presented some item here. Perhaps you want to know what are the items. So I followed the rules at the school. Is concerned to behavioral component. I feel excited by the work in the school, and I check my school work for mistake. And also we developed a new scale, teacher assessment of school engagement, to measure how teachers can rate a school engagement of a student. So it's kind of shared perception. So we collect the same information from the student and then from the teachers. One can better predict it. And also we collected some data on the school performance. So we use some items to measure the school performance in math, in science, and also reading and languages. As I mentioned before, so we developed a new scale of teacher assessment of a school engagement. So we needed actually to run some extra analysis, like exploratory factor analysis and perhaps confirmatory factor analysis in the future. So the result of primary exploratory factor analysis in the primary sample showed that 3 items was found for behavioral component, 4 items was found for emotional component, and also 4 items was found for cognitive component. And let's have a quick look on the result. So in the first step, we were trying to have a general look at the results. So we had a general school engagement reported by a student, and a general assessment of the teacher of the school engagement of the same student. And we wanted to know how these 2 ratings can predict math and science marks in the school. So as you can see in the first part, teacher assessment of the student school engagement could better predict the math score or math marks in the school than student report. And also we checked the same result concerning science, and we found the same results. We found that teacher assessment of a school engagement in general can better predict the math and science marks of a student in schools. And so in the second step, we try to go to detail. And so we also use some other school performance items like language marks and also reading. So I wanted to know again how the general assessment can predict these two school performance. So we found that again here, teacher assessment of a school engagement can better predict the language marks of a student in Russian school. And also we check again and we found that teacher assessment of a school engagement in general can better again predict the reading marks of Russian student in the school. And in next step, we try to again go to detail and to check not only the general assessment of teacher of a school engagement of a student, but we wanted to know how the three dimension of the assessment of teachers, like behavioral one, cognitive one, and emotional one, can predict this for school performance. So I show you the next result. So here, as you can see, we found that teacher assessment of emotional school engagement of a student was a better and stronger predictor of mass mark than other component rated by a student. So as you can see here in the second step, so teacher assessment, so when teacher says a student has a better emotional connection with the school, this could better predict the mass performance of a student in the school. And also, when we check the same result using the student report could predict the mass mark in the school. So in the next step again, we check the same result for science, and we found that teacher assessment of behavioral engagement could again better predict the science marks of a student in the school. But when we check for a student, so we found none of the dimension of a school engagement reported by a student could predict science marks of a student in the school. So that means if the teacher says this student is behaviorally connected with the school, it means this student, this evaluation can better predict the science marks of a student in the school. And so in the next step again, we went for language and also for reading. So we checked the same result, and we found that teacher assessment of behavioral engagement could be better predictor of language performance of a student in a school. And we check again for the language from the student point of view, and none of the component reported by a student could predict the language marks. I mean, when I say language bar or marks performance or school performance, these statistics are based on the real data we collected from the student. Yeah. And so in the last step, we were checking the same result, 3 components reported by a student and 3 components reported by teachers, to know which one is better predictor of reading marks in the school. And what we found was that, again, teacher assessment of behavioral engagement could better predict the reading marks in the school than the student. None of the student component of school engagement could predict the reading marks. And so I summarized the result here, as you can see. So general assessment of teacher of school engagement could better predict the math, science, language, and reading marks. And also teacher assessment of behavioral engagement could better predict the science, language, and reading. But teacher assessment of emotional engagement, this is the point here, could be better predictor of mass mark in the school. It means if the teacher could make a better emotional connection with the student in the school, it could predict a better mass performance in a student. And so let's have a quick look on the result. Yes, the first finding that could be reported here is that teacher assessment of a school engagement, we found that is more reliable determinant of school engagement and school performance in student. Also, as I mentioned before, a good emotional connection between teacher and student can considerably promote the mass performances in mass performance of a student, and participation of a student in a school-related activity, or put in the other word, behavioral engagement, can improve the student performance in science, language, and also reading. And educational consultant, if they are really want to improve the mass performance or other performances, for instance, in science, reading, and languages, they should think about specific types of engagement. And so in this study, we actually focus on shared perception of school engagement. And as I mentioned before, this is a small part of a running project. In the next step, what we are going to do is to subtract the score of a student from the teacher and to see which one is a better predictor of a school engagement and a school performance in a student. So thank you very much for your attention. Yeah.
Thank you very much for all the presenters. I think it was a great collection of different studies which allow us to see different aspects of psychology and math education. So let's go to questions from audience. Don't you have chairs for participants? У вас есть стулья поставить? Постоять? Okay, so the participants asked to stand here. No chairs, so. Okay. Okay, so please, do you have questions? No questions? Okay, Marco.
I have a question on methodology, and I think most of you would have something to do it with. I've done some comparative studies or using instruments developed in another country and then using them in Finland, or something developed in Finland and used in another country. Often it happens that the instrument doesn't work quite well. There are some items that don't work. And I think many of you used some translated instruments or translated yourself. So did you encounter these kind of things, that you took an instrument elsewhere, tried to implement in Russia, but you found problems with finding the right language that would, or the culture would be in such a way that the instrument doesn't work here? I would like to hear your experiences about this.
Okay, thank you. Вам надо перевести.
Он говорил о том, что мы используем иногда зарубежные методы для того, чтобы проводить свои исследования, если у нас возникают у нас трудности с тем, чтобы их использовать, адаптировать, перевести, и хорошо ли они работают у нас.
Thank you for your question. Actually, I work in a skill development and I'm familiar with this area. Yes, I mean, when I came to Russia for the first time, I was asked to develop a scale measuring a teacher assessment and also a school withdrawal. And when I was creating, because it has 3 steps. So first is item generation or creation, and the second is item selection by judge, and the third is item validation. And we faced a lot of problem in the second step, because there were a lot of English words that we couldn't find equivalent word for that. And that's why, I mean, I was very worried, or there were some similar word for in English, for instance, they have a different meaning, but in Russian they have, how to say, sorry, in English they have 2 different meaning, but in Russian they had 1 meaning. So that was really difficult to find some equivalent word for this. And I would say yes, but we try to overcome on this problem, and we use some different, and I would say very advanced research methods like measurement invariance. So when we were collecting data from one of the English-speaking country, and at the same time from Russia, we were using measurement invariance analysis to make sure that the item have been equally perceived before we conclude that the hypothesis is really significant or not significant or not. Before we reject it, we should make sure that the item has been equally perceived and can be transported from one culture to another. We had the same problem when I was in Belgium, because I was studying in Belgium, and there was the same problem about transferring one scale from Belgium to Africa, because some of the items were nonsense there. They couldn't understand what does that mean. And yeah, it's very normal, and I think it's not just related to Russian context, it's related to different countries. Yeah, thank you for question.
In our research, we used well-known method, t-test. That's why we cannot, they did not мы не испытывали трудностей, поэтому.
The question is not about the statistical test, about the instrument that you use.
Мы не
No translation here.
Thank you for the question. I highly agree with my previous colleague that because we use foreign methods, and of course it is a long time to adopt and to compare the results of foreign methods with some our traditional methods, and to provide some defense to use these foreign methods. And of course the most problems we have when we translated some language methods. And for example, with the math tasks, we have much less problems, of course. And some other tasks which didn't include the language component in so much. And but the using of foreign methods help us to compare our results with the results of the foreign investigations. That's why it's very meaningful to use them.
And I would like also to add, so we used rather standardized in Russia questionnaires, but the problem in Russia, I think we have a problem with diagnostic procedures and questionnaires in Russia, because most of the translated versions, they are rather old, and sometimes we have such sentences that our students, they can't even understand. So for instance, I'm not sure what's the English for сосёт под ложечкой, but there is, it's when you are in an anxiety, but this phrase, modern students, they can't understand. That's why we need to maybe create a new topic of this questionnaire. And not in this research, but I also participated in our professor from National School of Economics, High School of Economics, Shvitenko, in standardizing Big Five inventory. And that was about 4 or 5 years. So we translated from American English into Russian, then vice versa, and we needed to find representatives who was a native speaker in English and Russian, and they are rather good. So this is a rather long procedure in Russia. I think, like in other countries, this is a topical, up-to-date question. Thank you.
Do you want to say something? Yeah. Okay, I mean, there was an important thing came to my mind according to my past experience, so developing a scale. I want to say there is a big problem, and until now I couldn't find a solution for that. So when you develop a scale for the first time in non-English speaking countries, then it's less likely to be accepted by international community. And my question is why? Because I mean, we have done a lot. And that's why many of the people, I mean, I'm working with them, with Canadian colleague, Belgian colleague. I know they say, okay, the first time let's develop a scale in English, and then we conduct a study, collect data from an English-speaking country, and then when we validate it there, then we translate and adapt it to the second culture. And my question is why we should do that? Why we should just start with the data collection from an English-speaking country and then retranslate it and then adapt it? So do you have any solution for this problem, or do you have any logical reason that could help me to understand this heavy procedure? Yeah. Yeah, thank you.
Okay, do you have answers, Marco? I think it was directed to you.
I think I can mainly share your concern. Finnish is not either a language that would be very good starting point, but that's what we have to do when we do Finnish studies. So either we translate English surveys, or we try to develop some. If we develop something new, we have the same problem of getting it published.
Okay, sorry. Thank you very much for the nice presentation. I have a question to the third presenter, Anna. Okay, on your slide where there is risk zones or
Risk zone, yes.
yeah. Okay. So I would like to find out whether the first year student, are they all Russian or non-Russian? Because you say 40% they all fall under because of low adaptations. So is it a case even to non-Russian students or?
Thank you for your question. We actually regional university, so we are just in the middle between Europe and Asia. And we at the mechanics and mathematics faculty, we have only 2 or 3 international students. So all of these first year students, they are Russians. But the problem of adaptation, in my opinion, maybe and from psychological point of view, is that they need to change the pattern of working with knowledge that they get in school into the university level. So it's difficult. Our students, they don't know how to study, how to deal with big amount of materials, knowledge, and so on.
Okay, thank you so much, because this is something that I found in my study with but these are the first year Namibian higher school students, that they have also like low adaptation to the higher schools, because most of them, my participants, they were staying in a hostel. So that was a case that did have.
Yes, a part of our research was connected with international students and students who came from other regions. So our particular attention was for those who came from other regions. And for international students, we have groups from China, from Iraq, and from some African countries. And we also, as we provide psychological facilitation, we even can note some psychological aspects and diseases that appears when students study in Russia, like social and anxiety or like depression. It happens sometimes, and we have more particular attention for these students.
Okay, thank you so much.
Thank you. Okay, I would like to ask the first presenter about first of all the second factor that was that combined working memory, verbal working memory, and
cognitive flexibility.
And cognitive flexibility. It was strange for me, this combination. So I would like to hear explanation, and also the correlations with inhibition was negative. So how do you explain this? Thank you.
Okay, thank you for the question. I will start with the second question, okay, about the reverse connection with inhibition. Because high level of inhibition factors is related with a lot of mistakes and a lot of time while which children need to do the tasks, and this shows the low level of inhibition.
Okay.
If children spend a lot naming the figures in opposite way, it shows that he have low level of inhibition. Yeah.
Okay.
That's why the connection is with the minds. And first question about the second factor. I know it's quite new result, because in previous investigations usually we can see another factor system of executive functions, but in our country, on the sample more than 1,000 of preschool children, we have found this results of a factor analysis, and these two executive functions were combined in one factor. Maybe it's related with the measurements that we used, or maybe it's something which differ our preschoolers from another countries.
Okay, thank you. More questions?
A question with the most right from me, because I can't point yes to again to. I I forgot my question. There was too much of content, but I try to remember it just now.
Yeah, that's right.
Thank you very much.
Yeah, I agree.
I'm a student of Moscow State University, and I'm making a research on the topic how gender inequality is factors the gender mathematic gap. And I have a question for the first speaker, because you have investigated how beliefs of parents influence the some kind of the results and cognitive abilities of children. And it is a fact that women are better in verbal aspects, whereas men usually defeat girls in maths. But the fact is that in the right tail of the distributions, usually the gap is much more larger than in medium. And I have a question. Maybe you will bring some light to me, because what factors biologically influence cognitive abilities? Like, I mean, like, maybe some things. I'm sorry, just. I have it written. Yes. How do the parental beliefs and biological factors influence girls and boys in a different way? Have you put the sex of the children under control? That's my question.
If I may extend, I would like to also hear from the others if you saw some gender differences. I don't think any one of you reported that, but if you saw, it would be interesting to hear.
Thank you for the questions, very interesting. And of course, we try to analyze gender differences. And according to our results and according to my knowledge related with investigations from another countries, which were related with the gender differences in preschool children, yes? Usually girls have a little bit better results than boys, and such belief that boys are better in math and girls in language need to be to have some more information, because for me it's not so evidential and not so. I don't want to talk about the biological basis of that, because I'm not a neuropsychologist, I'm a developmental psychologist, and of course the culture and parents' beliefs I think affects this the development of preschool year children, but we didn't take it into account what parents think about how math meaningful for girls or for boys. We only analyzed how they feel that it's meaningful, the development of a person without gender differences between them. So unfortunately, I can't tell you some more new information. But in our investigation, girls was a little bit better in the development of their executive function and in math skills to have a little bit better results in some tasks.
Thank you. The other participants, can you pass the microphone?
In our opinion, there is not a difference between skills of girls and boys.
In our courses of higher mathematics and of Muscat, there are no difference. No, it is our opinion, but it is no. We studied not these questions.
Yes. Okay.
maybe in our case we can see the dynamics. So firstly, we didn't control this man-boys распределение. What's the English for? So the number of boys and girls in groups, but we can see the dynamics. So firstly, it was maybe traditional, like the faculty of mechanics and mathematics, they were boys. And in the very beginning, we have maybe 2 or 3 girls in groups of 30 boys. And now it's not the same because it's sometimes 30-70%. So it changes, but we maybe in future will try to analyze it also, because there should be some differences in this age.
Actually, we didn't test our hypothesis over gender because our sample size was not enough now. As I said before, it's a running project, so perhaps in July or August we can do that. But definitely I will do it, yes. Thanks.
Okay. More questions? You remember your question, great.
I can get back to slides, yeah.
And now there are 2 questions about your information collecting.
Yes.
The first about your difficulties. What about closed information? Did you need some closed information about our education? There are and a lot of closed information. And the second, how do you think, what do you think, would big data collecting help in your project?
I mean, thank
What do you
you.
mean by closed information? Just
Difficulty, you mean?
I think, first of all, the risk information. Information about risks and incidents.
I didn't get exactly the question, but I mean,
Any information about risks?
actually, I presented some information there. I mean, we conducted a study in Italy, not in this sample, in 2015, and we wanted to know how the school engagement is related to health risk behavior. There were 6 categories of health risk behavior, like consumption of alcohol, sexual activity without, for instance, condom, and things like that. So actually we found that, yes, so what we found, as I mentioned before, we found that when a student are highly engaged with the school, especially emotionally, they are less likely to get involved in this 6 category of health risk behavior. But in this sample we didn't do. If you mean, if by hard or difficulty you mean in data collection in Russia, yes, we had some difficulty, of course. Yeah, definitely.
And what about big data? Yes.
Okay, so I mean, I mentioned before that this is a small part of a bigger project funded by Russia. So the data collection is in process now, and we have some problem for data collection from the teachers, because sometimes when you collect data from the student, it's difficult for the teacher at the same time to rate the student. This is one problem, and the second problem is about the perception of a teacher of each student. I mean, sometimes the teacher might be in a good mood, so we'll rate everybody good, or high. And sometimes the teacher might not be in a good mood, so we'll influence the way that the teacher will rate the student. This is one of the problems. The second problem is about timetable. You know, in Russia, there are a lot of vacation. And then sometimes this may influence the data collection procedure. Sometimes we collect data from the student and teacher is not available to rate the student. So we have to wait after vacation. And some school, for instance, in Russia, they didn't collaborate with us. We went there and said, they said, okay, first we allow you to collect data. But after some time, said, no, sorry, we cannot. So we wasted a lot of time there for negotiation, going back, and finally we didn't get anything from the school. Yeah, but the good thing in Russia was that, as much as I understood, because we sent our student to a school, because I don't speak Russian, and bachelor and master student, they go to a school for data collection. The good thing is that in Russia, each teacher is responsible like for the first 5 years, I think, if I'm right, for each student. So we can rely on the teacher assessment of a student, because he or she, the teacher, has a good knowledge of each student. This is the good point, but it may not be found in other countries. I hope I have answered the questions. Yeah.
Okay, thank you.
Yes, of course. Your answer is brilliant.
Yeah. Thank you.
But electronic journal is not brilliant. And it is the only provider of big data in education.
Yes.
Okay, more questions. So let's thank presenters for great presentations.
Thank you.
And thank you for coming.
And may I also add some information? So on behalf of the Perm State University, we would like to invite all of those who are interested in psychology and technology of mathematics in higher education to participate in this collaboration and maybe to participate in our future conference. So we invite you for a future collaboration. Thank you.